So in this video, I'm going to show you how, when you start off with a Pixhawk flight controller, you can then get a quadcopter or hexacopter or multi-rotor up and flying. So it's going to go through all of the stages of setting one of these up in your multi-rotor to get flying. So things you're going to need: a Pixhawk flight controller, a receiver and radio. I'm going to use a Taranis radio with an X8R receiver. Now the receiver needs to support either S-Bus or CPPM. This one has S-Bus. If you've only got PWM outputs on your receiver, then you're going to need a PWM to CPPM or S-Bus converter module. There's loads of those available all over the place. They look like this. They're very cheap to buy. It takes all of your PWM inputs, combines them into a PPM output, or CPPM sometimes called. Right, and to power the Pixhawk, we're going to use a power module, because this will supply the power to the Pixhawk. It will also give us voltage measurement and also current measurement onto the Pixhawk. So for telemetry purposes, that's great. You'll need a male-to-male servo lead to connect your receiver to your Pixhawk. If you want to do loiter mode and autopilot modes, return to launch and things like that, you'll also need a GPS with compass. So this one is a GPS module with a compass built in. The Pixhawk does have an internal compass and it will use that as well, but it is far better using an external compass, since the Pixhawk is likely going to be near interference such as your power leads, ESCs and the other likes on the frame. So that would send the compass off by big deflections, which is only going to cause problems, and you'll end up with either toilet bowling or, worst case, it might do runaways. Right, so how to put this lot together. There's a bundle of software that we use. In our case, it's dead simple. We're just going to use Mission Planner. So you can get a copy of Mission Planner from rgpilot.com, go to the download section and download the latest version of Mission Planner. I'll put links to everything in the description below. And remember, if this video is useful, please give it a thumbs up. And in the forums, you'll notice lots of people asking the questions how to do these setups. So if you're on the forums, just put a post about it and a link to this video so that others that are asking the questions might find it useful. Right, so plugging in your GPS. The GPS, quite often you'll get a GPS and it will have either a 5-pin or a 6-pin plug on the end of it. For the Pixhawk, it uses a 6-pin plug. On the APM, it uses a 5-pin plug. And the only difference is that there's 2 gaps between the ground and the receive wire. On the APM, there's only 1 gap, so you can swap it out dead easy. So take the GPS, we plug that into our Pixhawk, and the other lead is the compass. That goes into the I2C port. So the compass plugs into I2C, the GPS plugs into the GPS port. The receiver will plug into the S-Bus port of our receiver, and that will plug into the RC in port of the Pixhawk. And in this case, ground is the top rail, signal is the bottom rail. Lots of people think plugging it into the S-Bus is the correct port. It's not. S-Bus is for output. It's not for input. Your power lead plugs into the power port. Bit tricky. There we go. That's in. And that would be basically it. So other than that, obviously you need your frame, motors and ESCs. Right, so binding your receiver, you'll bind your receiver to your radio. I won't cover that in this video. There's plenty of videos about how to bind your receiver to your radio. When I'm binding an X8R, I like to put the jumpers that it comes with. I put those jumpers across pins 1 and 2 and across pins 3 and 4 just to do the bind process. If I can get that one on. we go. So then you press down the FS button, plug power into it, it will put the receiver into bind, which means that I'm now going to get 16 channels out of my S-Bus port, but I'm going to get channels 9 to 16 on the PWM pins. That's really useful so as you can control external things such as gimbal tilt control or yaw control. Right, so once that's all bound up and you're happy, then you can go about mounting it into your frame. Here's one I prepared earlier. So this is one of our H500 Pro rigs. This actually uses a Pix Raptor that's embedded down into the middle of the frame. We use Hobbywing 40 amp ESCs because they've got a fantastic firmware on them, really fast response. We use RC Timer X4 3508 motors. They're 710 kV. They're spinning 12 by 4 inch direct fit props. It's Neo 8 GPS is standard. The X8R receiver. We have the 3DR radio telemetry as standard with these, along with the Mavlink telemetry through the X8R, so we get all the telemetry data fed onto the Taranis radio. These are great machines. They fold up very neat and tidy. So once they're folded, like so, the legs have got these little thumb screws, so you can just pop the legs off, and then the whole thing packs down nice and neat and tidy, and we pop them into one of these nice boxes. So it fits in a lovely, tough, waterproof carry case for carrying around for transportation purposes. But also this as a package will fit inside a rucksack and make for a great system that you can travel with. Right, on with the actual setup process. So the setup process that we're going to do is loading the latest version of firmware, which at the moment we're using the 3.3 beta firmware. The main reason for that is the 3.3 firmware is the first version they've done that is for Pixhawk only, so it's a true proper 32-bit version of the software. The previous ones were adapted such that they would still work with the APMs, which is an 8-bit processor system, but when running on the Pixhawk, it meant that the Pixhawk CPU was at about 80% load. Now that they've recoded that completely, redone all the code, made it pure 32-bit, it's now only running at about 10 to 15% load and has got a load of extra features. So without further ado, the first thing is we need a USB lead, micro USB port. We plug into our flight controller, connect up to Mission Planner, wait for our startup beeps, and you'll hear it connect and disconnect a couple of times from the computer on the COM port. That's just as the Pixhawk is booting up and registers the COM port. So we select the COM port, which should now show up in Mission Planner, and we set the baud rate to 115,200. If you're not sure, you can put it to auto, but I prefer to just make sure the COM port is showing up. If not, then you've probably missed installing the drivers that were getting installed as you installed Mission Planner. So you have to run Mission Planner install, and one of the questions it'll ask you halfway through is about installing drivers, and you have to authorize the install of those drivers, otherwise you won't get your COM port showing up. So we just go to Initial Setup and we're going to install firmware. So we click on Install Firmware. I don't want to use the 3.21 firmware. I'm going to go Beta Firmwares. Now it is still in beta at the moment. It's on release candidate 12 at the moment. That should get released very soon. They've done a couple of iterations of it, just ironing out little bugs. The bugs that they're seeing are just tiny differences. There's nothing preventing it flying. So we're happy to use that. So that's going to download it from the internet, and it's going to install it. It will often come up, depending where you've got your Pixhawk board from, most of the time, it will actually come up saying you're using unsupported hardware, which is fine. We just say OK, and it will carry on. The unsupported hardware is to do with the funding that the Pixhawk group used to have from 3D Robotics. So unless your Pixhawk has got a certificate of authenticity installed into the chip, one-time write chip inside it, with a valid serial number code and certificate, then it will come up with that warning. But remember, it is an open source hardware project and an open source software project. So there's nothing really about using so-called genuine hardware. People think that if they buy it from 3D Robotics, then they've got genuine hardware. It was not done by 3D Robotics, they merely funded the project. It was done by CTH in Zurich. So nothing really to do with 3D Robotics, but they did supply a lot of coding, they've supplied staff, and they supplied money to the project to keep it going. So we're grateful for that, but we don't like the fact that they're trying to keep it almost as if it's closed source and it's theirs only, because it's not, it's the community's. So that's now loaded the software on, and it's rebooted. We heard the tones, so we can then connect, and we're still plugged in via USB at the moment. So connecting over USB just to do the initial steps. After that, we're going to connect over the telemetry interface. That's going to fail to connect because I didn't reboot it after loading the firmware. So I'll just let it do that now. There. Reconnect it and reboot because it's had new firmware installed on it. Wait for it to boot up. There's our tones to say it's booted up. Now we can connect. Done. And if you go to our Google Docs, so the step we're going to now is config and tuning, and we're going to load a preset set of parameters. If you go to our Google Docs, I'll put the links in the description below. The Google Docs location, if you go to our shop, there's firmwares and files and parameters. There's a link there to the Google Docs. If you go to our YouTube homepage, there's a link there to our Google Docs, and I'll put one in the description here as well for you. So we're going to load the parameters from a file. We scroll down, we select our parameters file, say OK. It's going to highlight everything in green that it's updating. We say write parameters. So that's written all those parameters to the Pixhawk, or in our case Pixraptor, same thing. We can now go to initial setup and we'll start tuning. So the first section is mandatory hardware, and check that you've got the frame type correct. So in our case, we're on an X frame format, so we select the X. The next thing we want to do is accelerometer calibration, and we can still do that whilst plugged into USB because it's not that tricky. So we just leave it level, press any key. Put it on its left side. So I like to actually put it up against the wall so it keeps it nice and steady and level. Press any key. Right side. Again, level, any key. Nose down. Any key. Nose up. Any key. And turn it over onto its back. Just leave it laying on the bench. Any key. Calibration successful. Next step will be calibrating the compass. We're going to skip that because we'll get tangled with the USB lead trying to do it on the USB. So we're going to do the compass calibration over telemetry. So I'll jump straight to radio calibration. Turn on our radio. As mentioned, I've already bound the radio.
Active.
Okay. So now that we can see our radio in shot, as we put the throttle up, we can see the throttle on the green bar goes up and comes down as we put the throttle down. And we're going to check that each of those green bars follow our stick movements for the roll, throttle, yaw, except pitch. When you push forward, the green bar should go down. And when you pull back, the green bar goes up. Okay, so that's the only one that's slightly different because it's, I don't know, based on a horizon or something. The other thing you'll need is a flight mode switch, and you could do with a 3-position switch, or if you've not got a programmable radio, then just use a couple of 2-position switches with some mixing. But you can get away with the basic radio actually with 2 positions and just have loiter mode, alt hold mode, and then a separate switch for return to launch, which will be channel 7. So we've got some switches set up for switching channel 5, which is going to be the flight mode. And we can adjust that. So we're happy that we've got a few positions of that switch. So we now go to calibrate radio. Calibrate radio and follow the on-screen instructions. Say OK, say OK. And now all we do is we move the sticks for the full extent of their movement.
Altitude.
All of the switches for all of the channels that you've got configured. So I'm just going to do those 8. Click done, say OK, and it saves those settings to the board. The next one will be flight modes, and I'm just going to check that I've got the flight modes I want. So all of my switch up, I've got loiter, and I've got alt hold, and then I've got stabilize.
Altitude hold active.
The noise you can hear is the telemetry X8R Mavlink telemetry adapter I've got plugged in. So this screen shows up and I've got this radar panel, shows me how many satellites, the accuracy of that satellite fix in meters, so 2.3 meters based on 5 satellites, my altitude, max altitude, how long I've been armed and flying for, the flying speed, my heading, flight mode, voltage of the battery, how many amps I'm drawing, distance to home in the little radar, arrow points which way's home and it kind of floats around so you know where the copter is as well. And it also reports back what the actual flight mode
altitude hold active
has been selected. So you set your flight modes, hit save when you're happy with those. You've done the radio calibration, so now we're on to compass calibration, which to do that we need to disconnect. If you unplug, then it kind of crashes Mission Planner. Unplug the USB lead.
Telemetry lost.
And plug the USB lead into your telemetry. If you haven't got a telemetry adapter to do this with, so this is the 3DR radio telemetry system, basic radio telemetry system, 433 or 915 megahertz version. If you haven't got one of those, then just get yourself a long USB lead or USB extension lead. Right, now with a Pixhawk, the compass unit is in the right hand side of the board. So this is forward, there's an arrow on the front. The compass is in the right hand side. So when you set up your power cables, like the battery connection, try and have it so that they come on the left hand side of the flight controller. Okay, you ideally don't want power cables going down the right hand side of your Pixhawk flight controller, as that will just generate additional interference on the internal compass.
Telemetry recovered. Altitude hold active.
So I've got a telemetry adapter already plugged into this one. I've got a Neo 8 GPS, and we've got a combined buzzer and safety switch here. So on a Pixhawk we use a safety switch, which is this red flashing LED, and you press and hold that to activate the arming ability. So you can't arm it until you've pressed the safety switch. Most Pixhawks that you buy will come with a safety switch, otherwise you're going to have to disable the safety switch in the settings. Right, so now that we've plugged into the telemetry, we need to select the new COM port for this, which is going to be a Silicon Labs CP210X USB COM port, and the baud rate for that is 57600. If, again, the driver isn't showing up for this, then you need to install the Scilabs CP210 driver, and again I'll put a link in the description for where you can get that from. So we press connect, it says done, and it will just quickly load the parameters in from the flight controller into Mission Planner. And in Mission Planner you'll notice the title bar of the application now shows me APM Copter version 3.3-RC12. So I know that this flight controller has got the 3.3 RC12 software on it. So the other part I missed then, I thought I'd just add this back in here, was the tuning. So if you use our parameters, they are default set for our 650 Sport model. Now if you have a smaller quad like the H500 is slightly smaller, then you need to adjust these. Now the only figures you actually need to realistically play with under extended tuning is the rate, roll and pitch P. Now I have them locked so that they become the same, and if we just put these to 0.19 and 0.19 for the I, and I like to use about 7.5 for the stabilize, right params, then that'll be fine. So the last thing to do was the compass calibration. So we say live calibration, say OK. And now we just rotate that around on all of its axes. So horizontally. And whilst we're doing this, we're also going to look at the screen, because you'll see on the screen that it has two compass windows going around on the axes. And as I go horizontally like this, those red dots should float around the dark blue axes together. Okay, so the one on the left is my external compass, the one on the right is the internal Pixhawk compass. When I go nose up and rotate, we need both of those to be rotating on the, I think they call it teal, it's like a light blue coloured axes. If it's not rotating on the same axes, so both compass modules are rotating on the same axes, then you have to select the compass rotation, manual compass rotation. And you might find it's a yaw 180 degrees or yaw 90 degrees, but you can look at those axes that you're rotating on and you can work that out. So you can see whether you need to rotate the external compass by 90 degrees or 180 degrees. So we just rotate that around on each of those axes. So this is now nose down. Then if I rotate on that one, no, done that one, that side. So rotate it on the left side, rotate it on the right side. So this is now rotating on the green axes. And then turn it upside down. And that one is rotating on the yellow axes. That's about it. So once it's done all of its rotations, I'll just do a quick stable rotation. I was doing that on camera trying to keep it in shot, but it's not always that stable doing it that way. Okay, once it's finished, it will give you a beep to say that it's got enough data for the compass information. And it will then tell you that the offsets. Interesting, you're looking for those offsets to all be below, so below 300. So the first one I've got -211, -42 and 105. So that's all good. And the next one I've got -105, 29, -84. So they're all below 300, so we're happy with that. Much more than 300 offsets, it means you probably haven't got your compass stuck on quite straight, or the board's not quite straight. So try and get everything straight. We've accepted those, so that's finished. Now under optional hardware, we'll do motor test. The reason to do a motor test is when you plug your ESCs into the flight controller, they plug into the main outputs. Now we only need ground and signal of each ESC. We're not interested in the red wire because that just introduces more vibration into the flight controller. And if you go on the ArduPilot site, it shows you all the different types of craft and what the motor numbers are and the rotation of the prop for that particular motor number. They don't go round a craft or anything, they're kind of all hopscotch patterned around. Not sure why they wanted to do it that way, but so this arm is motor number 1. So the ESC for that arm plugs into port number 1 of the main out. Okay, so that will go into number 1, the ESC for that arm. And that one is rotating counterclockwise. Then this arm, which is the back left, so that was the front right. Now the back left plugs into port number 2. The front left plugs into port number 3. And the back right plugs into port number 4. So once you've plugged each of those motor ESCs in, all you need to do is just verify that. Now, I set this with the quad firmware, and when doing so, I basically told it it's a quad, so in Mission Planner it's going to give you A, B, C and D motors. They don't relate to those numbers. Okay, if you have a hex, it'll have obviously E and F on there as well. It'll have all 6, but those are going from the front right motor clockwise around the frame. Okay, so we've done our motor test. We've validated that each motor is turning the correct direction and that they're plugged in the right order. Next we go under optional hardware. They've got the compass motor calib. So it's the compass motor calibration. What that's going to do is measure the amount of interference on the internal compass and the external compass generated by the motors and ESCs and power circuit in here. Now that interference is measured in 2 ways. If you've got a power module powering your flight controller, then that interference is based on current draw. So it would be important to use an ammeter, or in my case I use one of these megameter things which measures the voltage and the current draw, and we basically have to calibrate our power module to read the correct voltage and the correct current draw. So the easy way to get to that is under config, tuning, full param tree, BAT. So battery is the battery monitor, which in our case we've got set to number 4. So if you use our parameters, it will set that for you. The battery voltage multiplier 10.3 is 10.1 is the standard that they have, but 10.3 gives us a more accurate reading for our monitors. And the battery amps per volt is set at 22 amps per volt. So you go under flight data and you can see the battery voltage and the current draw, and when you use your meter you're going to compare the two and make sure they're correct. If not, you need to adjust those figures so they are correct. If you're using our power modules from our shop, then it will be correct using our params. If you've got the power module from somewhere else, then you might have to adjust those figures slightly. So once you know that they're reading correct, we can now do a compass motor calibration. We will have the correct voltage, we will have the correct current measurement in place for the interference. So we press and hold our safety switch so we've got a solid red, so it's active. We've got our radio turned on because we're going to raise the throttle. On the screen, Mission Planner, we click start. And we just simply throttle it up slowly just to make sure everything's all okay.
Stabilize, active, telemetry recovered.
And we throttle up to just over halfway, hold it there for 5 seconds and then drop it back off. There we go. Of 10 or more, then you'll generally find it's not going to be very stable and you're likely to get toilet bowling problems. Okay, we like to see an interference level less than 10. If it's more than 15, I can almost guarantee you'll get a toilet bowling going on, because that's a lot of interference. If you've made sure you've routed your power cables away from the internal compass and well away from the external compass, the chances are that interference will be quite low. So that's that one done and completed. Press and hold the safety switch so that it's now safe again. The ESCs are beeping, so it's now safe. We've also got channel 8, by the way, configured on a switch here because that's the lost model alarm. So if you landed in some crop or tall grass, you can activate lost model alarm from the radio and home in on it. So we'll go back to the flight data screen. We're now ready for a test flight. So I'll just zoom the map in a bit so we can see where we are and where it is. There we go. And it shows us in the garage. And now we'll just transition to outside and do a test flight with it. So our test flight's going to consist of checking our flight modes.
Loiter active.
The parts we're interested in is a flight mode, because we don't want to start in loiter, not for the very first test. Right, so we're going to start with just stabilise mode. We've got our safety switch pressed, so we can now just hold the rudder right for 4 seconds to arm it.
System armed. Stabilize active.
And we put a little bit of throttle on, and we can just check that everything's going to fly around about right as we take off. So we can put a little direction control in, forwards, backwards, left and right, just to make sure. And just do a little bit of a takeoff, bring it up to a hover. I'm just doing a position move, forwards, backwards, left and right, and a bit of yaw, just to make sure that we're going to fly the right way and it's not going to suddenly just tip over. When we're happy with that, we could now go to alt hold mode. You have to bring the throttle well over halfway to about 75% before it will take off. And again, position movements, just to make sure, centre the throttle and it will hold that altitude. Whilst it's there, I'm going to switch to loiter mode, and it will then hold that position. There's a little bit of twitching going on still there, so I've maybe got those settings a little bit too high. And it's quite a windy day today as well, so that's not helping matters. So that's about right. Just bring that up a touch higher. There we go. So if we push that, bob it around, that's quite a stable flying machine. So if we then do push it forward a little bit and just do a rotate, so let that settle down. Just do a quick rotation to make sure it's not going to run away somewhere. And that just tests the compass to make sure that the GPS and compass are doing their job and holding the position of the copter. So as long as that doesn't do big toilet bowling and wandering around, then you can be quite confident that when you do a return to launch, it will actually come back to home for you. And as we can see on the screen here, we've got our little radar, and if we rotate it, we can see our little radar turning at the same time. And if we fly it away a little bit, can't go much further because I'm in the garden, then we can see 6 meters and we can see the arrow for the direction that it is. So if I rotate that around, I can see that it's now pointing back to home, flying it on that, 4 meters, 3, 2, and it's home. And then land. You sometimes find the motors don't immediately go to idle, and it might tip over depending on the landing skids that you've got. If that happens, just switch it to stabilise mode with the throttle down. It'll idle the motor straight away and then you can disarm. That disarm because I hadn't done anything with the throttle for more than, I think it's 10 or 15 seconds.
Altitude hold active.
So I hope that helps. Again, like I mentioned, please give it a thumbs up and also put a link to it in any of the forums that you're talking to people about Pixhawk setups so that they can work their way through the video. When you've finished, always press your safety switch. If they have questions about it, then at least this video might help them out and get them to flying. Okay, thanks.